Home Assistant can do a lot when it comes to home automation, and one major component is in the name, and that is automation. To have automations, you need to have a way to create and manage those automations, and in this video, we'll be going over 3 different ways you can set up automations in Home Assistant. To better show the differences between the 3 methods we will be covering, we will go over how to create the same 3 automation rules within each method. The first one is pretty simple, and that will be to turn a closet light on when the closet door opens, and turn it off when the door closes. The second automation will be controlling multiple light switches from the double-click action of one light switch. I use this automation heavily in my kitchen for 5 different light switches, and it is one of my top 10 all-time favorite automations. The automation itself is kind of simple, but with so many light switches, there is a layer of complexity that can be sometimes challenging to get right. The last automation we will cover for all 3 methods will be my porch light control automation. This one not only utilizes the sunset to determine when to turn my porch lights on, but also utilizes a motion sensor to turn the lights back on after a certain point at night. Keep in mind that this video will not be a full walkthrough on how to set up these automations. Instead, they are meant to help show a small example of what automations within the different methods can look like. The first way to do automations on Home Assistant that we will be taking a look at is with the built-in automation editor. Nothing special is needed, and it's ready to go right with your installation of Home Assistant. To access the automation editor, navigate to Settings, Automations and Scenes, and then make sure you have automations selected on the top tab. If you have any automations already set up, you'll see them here along with the last time they have been triggered and if they are disabled. Clicking on the blue button titled Create Automation will give a pop-up asking if you want to create a new automation or use a blueprint. We'll talk about blueprints a little later, and for now, click on Create New Automation. From here, you can easily see the 3 building blocks for an automation: triggers, conditions, and actions. Triggers are what starts the processing of an automation rule. When any of the automation triggers become true, Home Assistant will evaluate any conditions and then call any configured actions if appropriate. An automation can be triggered by an event, a certain entity state, at a given time, and more. These can be specified directly or more flexible via templates. It is also possible to specify multiple triggers for one automation. Conditions are an optional part of an automation rule. They can be used to prevent the automation's actions from being run. After a trigger occurs, all conditions will be checked. If any of them do not return true, the automation will stop executing. And lastly, the action of an automation rule is what is being executed when a rule is triggered. Conditions can also be part of an action. You can combine multiple service calls and conditions in a single action, and they will be processed in the order you put them in. To add a trigger, condition, or action, simply click on the Add button under the appropriate section. Doing so will provide a drop-down with several different options. As can be seen, there are several different options for all 3. With the automation editor, you're able to fully extend the automation capabilities by utilizing scripts to add in complexity. The next way to do automations in Home Assistant that we will be looking at is with SharpTools. SharpTools is both a rule engine and dashboard that can actually work with several different automation hubs like Home Assistant, SmartThings, and Habitat, just to name a few. The ability to work with different hubs is also extended with the added bonus of being able to have automation rules that can be triggered by devices on one hub to control devices on a completely different smart hub. To use SharpTools with Home Assistant, you'll need to install an add-on, authorize access to your Home Assistant deployment, and then authorize which entities you want shared with SharpTools. This is pretty nice, as it gives you granular control over what SharpTools can and can't see, and you're able to pull back device access whenever you want. One downside, though, is that you can't have new devices automatically authorized. You need to remember to go back in and add them. SharpTools utilizes a visual editor for all automation rule creation. Just like in the Home Assistant automation editor, SharpTools automations can be triggered by several different aspects of a connect device changing, variables, or even HTTP triggers. You can also use the exact time of day, the sun rising or setting, or even a repeating schedule as well for a trigger. When a rule is triggered in SharpTools, the rule flow is executed top-down. The rule flow can then be used to send commands to devices for control, such as turning a light on, opening a garage door, or even playing music. Within a flow, you can have if conditions, which then allow for the ability to have things occur under certain circumstances or to create more complex logic. SharpTools has both a free version and a paid subscription to unlock more advanced features, which costs $30 USD a year at the time of this recording. The last automation tool we'll be looking at for Home Assistant in this video is Node-RED. Node-RED is an independent tool originally created by IBM that is meant to allow for easily connecting hardware devices, APIs, and other online services together. Node-RED is flow-based, utilizing visual programming through a web browser, and is written in JavaScript built on Node.js. Thanks to the modular nature of Home Assistant and its support for add-ons, you're able to install Node-RED and use it as part of your Home Assistant installation pretty easily. For this video, I will not be covering how to install and set up Node-RED, but it can be found in the add-on store and is really easy to set up. Node-RED utilizes nodes within flows for home automation rules. A node can have inputs, outputs, or both. At a high level, you still have triggers and actions, just like with the automation editor in SharpTools, and you can set up conditions as well to add in more complex logic. Let's now walk through creating our first automation rule with all three automation options. The first automation will be turning on a closet light when the door to the closet is opened, and then having the closet light turn off when the door is closed. This is a super simple automation, but still one that I use dozens of times a day throughout my home. To access the automation editor, navigate to Settings, Automations and Scenes, and then make sure you have Automation selected on the top tab. Click on the blue button titled Create Automation and click on Create New Automation. Next, click on the Add Trigger button. From the drop-down, we are going to select Device, which will put a device trigger under our Triggers section. Clicking on the Device drop-down will give us a list of all the current devices Home Assistant knows about, and I will be selecting my bedroom closet contact sensor. Then, under the Trigger drop-down, I will be selecting Is Opened. If you want to have the door be left open for a specific amount of time before triggering, you can set that under Duration. Next, we need to add our second trigger of when the closet door is closed. We'll again click on Add Trigger, select Device from the drop-down, and then select the bedroom closet door contact sensor. This time, we will be selecting Is Closed as the trigger. With what we have currently set up, the automation will be triggered when the closet door is opened and closed, and will run anything we put under our Actions section. Because of this and how I'm doing this automation rule, we'll need to assign trigger IDs to both of our triggers, which will be referenced in our Actions section later on. If you aren't familiar with trigger IDs, don't worry, as we will be going over them right after we finish creating the automation. To add a trigger ID, click on the three-dot menu for the device trigger, and select Edit ID. Doing so will show a new field called Trigger ID. This field will be used later on, so I want to make sure it's something I understand, and I will be using Bedroom Closet Open. For the second trigger, I'll be naming the trigger ID Bedroom Closet Closed. Now it's time to add in our actions for this automation. The first trigger will be turning the closet light on, and we only want it to happen if the closet door was opened. To do this, click on the Add Action button. And then we will be selecting If Then to help us take advantage of our trigger IDs from earlier. Next, click on Add Condition, and select Trigger By on the drop-down menu that appears. This will give us a list of every trigger ID we created in this automation rule. For this trigger, we will be selecting the Bedroom Closet Open trigger ID. Finally, we need to add our action by clicking on Add Action under Then. Doing so will give us a list to select from, and we will pick Device. Next, we will select our bedroom closet light with an action of Turn On. We now need to create our second action to turn the closet light off when the door is closed. Start by clicking on Add Action under the first action block we added. We will again select If Then in the list that appears. Next, click on Add Condition, and select Trigger By on the drop-down menu that appears. For this trigger, we will select Bedroom Closet Closed. Lastly, we will add in our device action for the bedroom closet light, and this time have the light turned off. Now that we have everything built out, we can save our automation and give it a name by clicking on the blue Save button on the bottom right-hand side of the screen. Doing so will give you a pop-up window where you will name the rule and are able to give it a description if you'd like. A quick tech tip: within the automation editor, you can actually rename each of the blocks within a rule. This allows you to have a more meaningful name for what a block does, without having to expand each block and look through them all. To rename a block, simply click on the three-dot menu for the block you want to give a new name, and then click on Rename. You will then get a pop-up window where you can put in your desired name. You can then go through and rename any of the blocks you want. Just make sure to save the automation afterwards for the changes to stay after you leave the page. And with that, we have created an automation in Home Assistant with a built-in automation editor to turn on a closet light when the door is opened, and turn the light off when it's closed. Let's now test out our automation. Great, opening the closet door turns the light on as expected, and turns it off when the door is closed. Let's now walk through how this rule is evaluated within Home Assistant. When the bedroom closet door contact sensor changes its state to open, the rule is triggered. Next, any conditions in the rule are evaluated. If any conditions in the rule are not true, then the actions are not run. Because we don't have any conditions in this rule though, we don't have to worry about it. After the condition check is passed, each action will be executed from the top down. Our first action is an if statement, which will be evaluated. In our case, the if statement check is if the trigger ID is bedroom closet open. In this instance, because the trigger was the door opening, the trigger ID matches, and the if evaluation is true. Since the if evaluation is true, everything under then is executed, which in this instance is turning the closet light on. Next, the second if then block is evaluated. This happens because the rule evaluates all actions, even though the first action occurred. The second if block checks the trigger ID once more, but is looking for closet door closed. In this instance, the trigger ID does not match, so the then actions are not executed. When the door closes, the rule evaluation will occur again. No conditions mean the actions are allowed to run. The first if block statement is checked, but this time it's evaluated as false because the trigger ID does not match. With the check being false, the actions under then are not executed. The second if block statement is then checked. In this instance, the trigger ID will match with bedroom closet closed, and the actions under then will be executed, which will turn the closet light off. This is a great time to circle back to trigger IDs. If we had not set them up, then we would just have two actions, one to turn the light on and one to turn the light off. Both actions would have run, resulting in the light turning on and then off, which isn't very helpful. So instead, you'd either have to make two separate rules, one for opening of the door and one for closing of the door, or you can just use trigger IDs. You could also use the device state being opened or closed as the if block check, but that's not as much fun, and then I wouldn't have had an excuse to talk about trigger IDs. It's also a bit more efficient in my opinion to use trigger IDs. If you wanted to make the automation rule a little simpler, we actually can add an else action at the end of the first if block that will turn off the light. To do this, expand the turn on bedroom closet light action and click on add else at the bottom of the block. Next, click on add action under the else section that just appeared. Here you will select an action type of device and then select the closet light turning off. The way an else functions within an if block is that it will be executed if the evaluation of the if statement is false. So in our example, anytime the if block is evaluated and the trigger ID is not bedroom closet open, the closet light will be turned off. With the else statement, we can actually get rid of the other if block, turning the light off, as it will be taken care of now. And as always, make sure you save your automation after making any changes to it. Let's now go over creating the same automation in SharpTools. From within the SharpTools rule engine, click on the green plus sign at the top of the screen. On the page that opens up, give your automation a name. You can also give it a description if you want. Next we will add just one trigger, which will be when the contact sensor contact state changes. To add a trigger, click on the plus sign under Triggers. Next, click on Event Trigger. After, click on Device and select Choose Thing, which will open up our device picker. Next, we are going to search for and select our bedroom closet door contact sensor. With the contact sensor selected, we'll need to select the attribute, which in this case will be Contact. Next, change the operator to Updates, and then click on Save for the trigger. With what we have currently, the rule will trigger anytime the contact for our contact sensor updates, which includes it changing to opened or closed. Next we will add two actions to the rule flow, one for turning the closet light on and one for turning the closet light off. To do this, click on the plus sign under Flow, and then we will click on If Condition. Under Condition, click on Device, and select the door contact sensor. After, change the attribute to Contact and make sure the operator is set to Is. Next, set the option to Open, and click on Save for this condition. Now we will add an interaction of turning the closet light on under the Then block, by clicking on the plus sign under Then. From the options that appear, we will select Action and then select Device. Under Choose Thing, we will search for and select Bedroom Closet Light. Next under Command, select On, and then click on Save for the action. Now if the bedroom closet door is open when the rule is triggered, the closet light will turn on. Let's add turning the light off on the door shutting. We'll first click on the plus sign under the if block we created, and select If Condition once again. Under the condition, we will select Device and again search for and select the closet door contact sensor. For this condition, we will be selecting the contact is closed. Lastly, we need to add interaction under our Then. The only difference from the previous if block is the closet light will be turned off. Make sure the trigger and everything in your rule flow is saved, and we can click on Save at the bottom of the page. Let's now test out our automation. Great, the closet light turns on when the closet door is opened. And the light turns off when the door is closed. Let's now walk through how this rule is evaluated within SharpTools. When the bedroom closet door contact sensor changes its state, the rule is triggered. This means if the door is opened or closed, the rule will be triggered. Next, the rule flow is evaluated top down. The first if block is evaluated to see if all the conditions are true, which in our example, there's only one condition of the bedroom closet door being open. If the contact is open, the actions under then are executed. In this automation, if the condition check of the first if block is evaluated as true, then the bedroom closet light is turned on. After the first if block is evaluated, the second if block in the rule flow will be evaluated. If the contact is closed, the actions under then are executed. In this automation, if the condition check of the first if block is evaluated as true, then the bedroom closet light is turned off. If you wanted to make this automation rule a little simpler, we can actually just add the bedroom closet light turning off under the first if block. In this simpler automation rule, the actions under then will run when the condition of the contact sensor being open is evaluated as true, which then turns the light on. If the condition is evaluated as false, then what's under else will instead be executed, which in this example would be to turn the light off. Let's now create the simple automation one more time, but in Node-RED. Within our flow canvas, we'll first put an event state node down. Next, double-click on the node to edit it. I like to give my nodes meaningful names, and I suggest you do as well to make troubleshooting and rule creation a lot easier. After your node has a name, we are going to select the bedroom closet door contact sensor entity, then under state, we are going to type in the word on. Once all set, you can click on Done at the top of the node editor window to apply the changes to your canvas. Next, add a call service node to the canvas and double-click on it to edit it. Under Domain, select Light, and then under Device, we are going to select the bedroom closet light. For service, we are going to select Turn on this node. Click on Done to apply the node changes. Next, click and drag from the top right connector on the bedroom closet door open node to the left connector on the Turn on bedroom closet light node. You should have a connection like mine. We now need to create the same two nodes, but this time for when the door closes. We'll first place another event state node on the canvas and edit it to be for a bedroom closet door. This time, for the if state, we are going to enter in the word off. With the first node completed, we can add a second call service node, configuring it similar to the first one. The domain will be light, the device will be the bedroom closet light, and this time, for this service, we will select Turn Off. After, click and drag from the top right connector on the bedroom closet door close node to the left connector on the Turn Off bedroom closet light node. Lastly, we actually need to save this canvas. To do that, click on the Deploy button at the top right hand side of the screen. Now that our automation is deployed, let's test it out. Great, the closet light turns on when the door is opened, and turns off when the door is closed. Let's now walk through how this rule is evaluated within Node-RED. The two event state nodes are subscribed to events for the configured entity, which in this case is the bedroom closet door. When the entity state changes, the nodes evaluate to compare to the configured if state. If the state is evaluated as true, a message is sent out the top output. If the state is evaluated as false, then a message is sent out the bottom output. This means when the closet door state changes to open, a message is sent out the top output on our top node, since it was evaluated as true, and a message is sent out the bottom output on the bottom node because it was evaluated as false. Likewise, when the closet door is closed, a message is sent out the bottom connector on the top node because it's evaluated as false, and a message is sent out the top output connector on the bottom node because it's evaluated as true. So with our automation, when the closet door is opened, a message is sent out the top connector on the top node, which then triggers the call service node to turn the light on. For the bottom event node, we have nothing connected to the bottom output, so nothing happens. When the closet door is closed, a message is sent out to the top connector of the bottom node, which is connected to a call service node that turns the light off. To simplify this automation rule a bit further, we can actually take advantage of the false output of the top event node by connecting it to the turn off bedroom closet light call service node. We've gone over creating a pretty simple automation in the Home Assistant Automation Editor, in SharpTools, and in Node-RED, which has hopefully shown the similarities and some other differences. But in order to really see where the different tools shine, I think we need to take a look at some more complex automations. The next automation we are going to take a look at is another one of my all-time favorite smart home automations, and that is taking my 5 individually wired kitchen lights and making them able to turn on or off all of the kitchen lights with a simple double press. For 4 of the 5 lights, when they are double pressed up, they will actually only turn on 4 of the lights. However, if the kitchen table light switch is double pressed up, then all 5 of the kitchen lights will turn on. Likewise, if any of the 5 switches are double pressed down, all lights are turned off, including the kitchen table light. For this automation, we won't be walking through the rule creation, but instead we will be taking a look at the completed automation rule in the Home Assistant Automation Editor, in SharpTools, and in Node-RED. In the Home Assistant Automation Editor, we rely heavily on trigger IDs to help keep everything in one automation rule. Each light switch has two triggers, one for being double pressed up and one for being double pressed down. And each trigger has a unique trigger ID that will be referenced in the actions. Because there are 5 light switches, there are 10 total triggers. This rule has no conditions, so the actions will always run when the rule is triggered. Under actions, we have 3 different if-then blocks. The first block is for turning on all of the kitchen lights when the kitchen table light is double pressed up. It has a single if condition looking for the trigger ID of kitchen table light on. If it's evaluated as true, the events under then will be executed. When executed, the if block will do 2 things. One will be to turn on the kitchen table light to 100% brightness. The second will be to turn on a device group I have created called Kitchen Lights. In this group are the 4 other kitchen lights. Having the group set up makes this automation a little easier and allows me to add or remove devices if I want without actually having to touch the automation. The second block is for turning on all of the kitchen lights except for the kitchen table light when any of the other 4 lights are double pressed up. It also has a single if condition looking for the trigger ID of the 4 different lights. If the trigger ID is any of the 4 lights, it will be evaluated as true, and the events under then will be executed. When executed, the if block will do one thing, call the service light turn on for the kitchen lights device group that contains all 4 of the lights. The third and final if block has a single condition looking for a trigger ID that indicates any of the 5 light switches have been double pressed down. When executed, there are 2 actions that will occur. The first is the light turn off service will be called for the kitchen light device group. The second is the kitchen table light will also be turned off. Let's now see this automation in action. Great, when the kitchen table light is double pressed up, all 5 of the lights turn on. And when the island light is double pressed down, all of the lights are turned off. The same automation rule can also be created in SharpTools. For the rule, it'll have only 2 device triggers, and takes advantage of a newer feature allowing for multi-device event triggers and actions. Before, you would have to have multiple triggers or actions if you wanted to work with multiple similar devices, like light switches or light bulbs. But now, you're able to have one trigger or action as long as the devices are similar, and the trigger or action is going to be the same across all the selected devices. This feature has really helped make some more complex rules simpler, and this rule is a great example of it. The first trigger will be if any of the 5 kitchen lights are double pressed up, and the second trigger will be for if any of the 5 light switches are double pressed down. The automation rule has multiple if blocks in the rule flow. The first if block has 2 conditions. The first condition checks to see if the event value of the trigger contains up_2x, which is what SharpTools sees when these particular light switches are double pressed up. The second condition checks to make sure that the name of the device that triggered the rule flow evaluation is not the kitchen table light. Because of the AND between both conditions need to be evaluated as true for the actions under then to be executed. If both conditions are evaluated as true, then all of the kitchen lights except the kitchen table light will be turned on. The next if block checks again for the up_2x event value, and this time checks for the device trigger name to be kitchen table light. If both conditions are evaluated as true, then all 5 of the kitchen lights will be turned on. The last if block checks for a single condition, which is if the trigger event value is down_2x, which is what SharpTools sees for my light switches when they are double pressed down. If the condition is evaluated as true, then all 5 of the lights are turned off. Let's now see our automation in action. Great, when the kitchen walkway light is double pressed up, only 4 of the lights are turned on as expected. Likewise, when the kitchen table light switch is double pressed down, all of the lights are turned off. Let's now take a look at this automation one more time, but in Node-RED. Within Node-RED, we have a single events node that is checking for a specific Z-Wave event to happen. When it does, a message is sent to a switch node. The switch node is checking the message for the event node ID, which correlates to the Z-Wave device ID for my Home Assistant deployment. If the node ID is a match in the switch, a message is sent along the flow from a specific output on the node. A quick tech tip: you can find the Z-Wave device ID by going into the device page for your Z-Wave device and expanding the Z-Wave info section under device info. Here you will see what Z-Wave version the device is, if it's connected with security, and the device ID. As can be seen, my kitchen island lights have a device ID of 26. 4 of the outputs lead to the same subflow node, and the last one goes to its own subflow node. The 4 that go to the same are for the device IDs for the kitchen lights, while the one that's by itself is for the kitchen table. The 2 subflow nodes are exactly the same, just broken out for more granular control of the lights. Within the subflow, the scene ID is checked. Depending on if it equals 1, 2, or 3, will determine the output that's used for the message to be sent. Each output is then connected to another switch node. The top switch node is for if the light is pressed up. Within the switch node, the event value is checked and is used to determine how many times the button is pressed, and correlates to an output which is then translated as an output for the subflow. The same thing occurs with the middle switch node, but this time for the switch being pressed down. And the last switch node is used to check for the configuration button being pressed, which I do not use in this automation. Going back to the main automation, the outputs from the subflow node are connected to one of 3 service call nodes, depending on if the top or bottom is double pressed on the switch. The top call service node will turn on all the kitchen lights except for the kitchen table light. The middle call service node will turn off all the kitchen lights, including the kitchen table light. The bottom call service node will turn all the kitchen lights on, including the kitchen table light. Let's now test out the automation and see how it does. Great! When the kitchen sink light is double pressed up, 4 of the kitchen lights turn on as expected. And if the kitchen table light is turned on by itself, and then the kitchen island light is double pressed down, all 5 of the lights turn off. We've now gone over creating a pretty simple automation in the Home Assistant Automation Editor, in SharpTools, and in Node-RED, as well as a pretty helpful semi-complex automation. Let's take a look at one more automation to really help showcase the differences between the 3 different automation tools we've been looking at. This final automation will control my front yard lights. 45 minutes before sunset, the lights will turn on. Then at 4 a.m. every morning, the lights will turn off. Lastly, between 4 a.m. and sunrise, the yard lights will turn on for a short period of time when a motion sensor is triggered. Within the Home Assistant Automation Editor, we have 3 triggers, each having their own unique trigger ID. The first trigger is for 45 minutes before the sunset of my hub location. This time gets updated automatically based on location, which is nice because for me, I can have sunset at 4 p.m. or 9 p.m. depending on the time of year. The second trigger is a simple time trigger of 4 a.m. The third trigger is for when my motion sensor detects motion. This automation has no conditions, so you don't have to worry about them. The automation does, however, have 3 if-then blocks under actions. The first has a condition check for the trigger ID called sunset. If it's evaluated as true, then the front yard lights are turned on. The second if-then block checks for a trigger ID of 4 a.m. If it's evaluated as true, the front yard lights are turned off. The last if-then block has 2 condition checks. The first is if the trigger ID equals motion, which is the trigger ID for the motion sensor detecting motion. The second check is if the time is between 4 a.m. and the sun next rising. If both are evaluated as true, then 3 things occur. First, the front yard lights turn on. Then, the automation waits 5 minutes. And then lastly, the front yard lights are turned off. Now, one important thing that isn't easily noticeable for this automation rule is the automation mode. By default, all automations are created with a mode of single. What this means is that when an automation runs, a new instance cannot be started until the first one is completed. If there is an attempt at running a second instance of the automation rule, a warning will be issued. This can be a problem in our automation because if the lights were turned on by motion, the first instance of the automation rule being evaluated as true will be stuck waiting for the 5-minute delay. Anytime motion is detected after that, a warning will be issued. Not only is that annoying, but if motion detection keeps occurring, the timer will not be reset, and the lights will turn off 5 minutes after motion is first detected, which makes this automation not as useful. Instead, we will want to use a different mode, which there are 4 total currently possible. The first is single that we already talked about. The second is restart. In this mode, a new instance of the automation will be called after stopping the previous run. The third mode is queued. In this mode, a new instance of the automation will run after the first run is completed. The last mode is parallel. In this mode, a new independent automation instance is started and runs in parallel with any previous instance. For this automation, we are going to want to use the mode restart. To change the mode of an automation, click on the 3-dot menu at the top of the screen next to Traces and click on Change Mode. Next, click on the drop-down menu and select Restart. Then click on Change Mode. Finally, click on Save at the bottom of the screen. Let's now test out our automation. As expected, the front porch lights turn on before sunset and turn off at 4 a.m. Likewise, when the motion sensor detects motion between 4 a.m. and sunrise, the lights are turned on for 5 minutes. Let's now take a look at the same automation built in SharpTools. This automation is actually going to be done with 2 separate automation rules. The first will be for controlling the lights based on time of day, and the second will be for controlling the lights based on motion. Within the first SharpTools rule, we have just 2 triggers. The first is a time event that will trigger every day at 45 minutes before sunset, and the second trigger is another time event that will trigger every day at 4 a.m. For the rule flow, we have a single if block that checks if the current time is before sunset. If it's evaluated as true, then the porch lights will be turned on, which will always be the case with the first time trigger of 45 minutes before sunset. If it's evaluated as false, then the porch lights will be turned off, which will always be the case when the second time trigger of 4 AM occurs. In the second SharpTools automation rule, there are also 2 triggers. The first trigger is if the motion sensor detects motion, and the second trigger is if the motion sensor stays inactive for 5 minutes. This automation then has a few if blocks in its rule flow. The first has 2 if conditions. If the event value that triggered rule evaluation equals inactive, and if the current time is between 4 AM and 9 AM. This will happen when the motion sensor staying inactive for 5 minutes triggers between 4 AM and 9 AM. If the if block evaluates as true, the lights will be turned off. The second if block has 3 conditions that must be true for its actions to be run. For this if block to be evaluated as true, the event value that triggered rule evaluation must be equal to active. The time must be after 4 AM, and the time must also be before sunrise. If all 3 conditions are true, then the if block will be evaluated as true, and the lights will be turned on. Let's now test out the automation. Great, as expected, the front porch lights turn on right before sunset, and turn off at 4 AM. Likewise, when the motion sensor detects motion between 4 AM and sunrise, the lights are turned on for 5 minutes. Let's now go over our yard light automation built out in Node-RED. Within our Node-RED automation, we have a few different things going on. So let's start at the top and work our way down. First, we have a time node of 45 minutes before sunset. When the node is evaluated as true, the front yard lights are turned on. Next, we have an inject node that is used as a time trigger. It is set to run every day at 4 AM. When it does, the front yard lights are turned off. Lastly, we have a trigger state node that is looking for the outside motion detector to detect motion. If the node is triggered, a message is sent to a time range node. The time range node will be evaluated as true, which is referred to as within for this node, if the current time is between 4 AM and sunrise. If the time is within that, then the lights are turned on. After the lights are turned on, a message is sent to a trigger node that is configured to wait for 5 minutes. The trigger node is configured to extend delay if a new message is received, which means anytime motion is detected again, the wait timer will restart. The node is also configured to then send the latest message object after the time is up, and it is configured to reset the trigger if it receives a message with the payload to stop. Once the 5-minute timer finishes, the yard lights will be turned off. Let's now test out the automation. Great, the porch lights turn on and off when expected, and when the motion sensor is triggered, the lights will turn on for 5 minutes. Now that we've gone over setting up a simple automation in the Home Assistant Automation Editor, within SharpTools and in Node-RED, along with taking a look at 2 more complex automations, let's go over some major similarities and differences between the 3 automation options that I feel are important to consider before deciding on which way you should go. First up is ease of use. To me, the Home Assistant Automation Editor and SharpTools are a little easier to pick up on how to navigate with simple drop-down menus, while Node-RED will take a bit more time to get the hang of things, due to the amount of customization and control you have access to, which also leads into the learning curve for getting started with the different automation tools. If you're just starting your home automation journey, or don't really have a background in any type of programming, you are probably going to find Node-RED to be the most difficult to get started with, as it has a much steeper learning curve in my opinion. And while the built-in automation editor of Home Assistant isn't super complex to learn, I did initially find trouble in figuring out how to get certain things to work within automations, even though I've had several years of automation rule creation, both within SmartThings and with WebCore. I do think part of this was just from the learning curve coming from SmartThings, but it's really hard to say. For me, SharpTools was the easiest to pick up and figure out how to create the 3 automations we went over in this video. The automation editor wasn't that much more difficult, but there were a few oddities I ran into throughout that took some time to figure out. While all 3 options provide a great range for the ability to create different types of automation rules, Node-RED by far provides probably some of the greatest range when it comes to complex rule creation. Once you get the hang of things within Node-RED, you're able to create some really complex automation rules that might require multiple rules within either the automation editor or SharpTools. The Home Assistant Automation Editor does support automation blueprints. Blueprints allow for you to easily template an automation rule that then can be reused while making small tweaks. Another great function of blueprints is the ability to import others' automation rules, which can be helpful to accomplish certain tasks that might be more difficult to figure out how to do. Overall, as long as you're okay with the steep learning curve, Node-RED could be a great choice if you're looking to have some very complex home automation rules, or if you're looking for the most visual option when it comes to rule creation. Keep in mind that Node-RED is basically impossible to use on a mobile phone, as I know that can be a deal breaker for some. With SharpTools, you should be able to quickly learn the basics of rule creation, and it works pretty well with mobile devices too. One great feature of SharpTools is the ability to have multiple smart home hubs connected together. This is great if you're transitioning from one smart home platform to another, or if you just have multiple smart home hubs for some reason. The built-in automation editor for Home Assistant is a well-rounded option, and works great on mobile devices. The learning curve is not that complex, and you don't have to take any extra steps to get started with it, which is always good. Realistically, there is no right or wrong answer on which to pick, and maybe a combination of two or all three will end up working for you. I strongly encourage taking a look at all of your options and seeing which might make the most sense for your use. One thing that's really great about home automation is that there are usually several different ways to accomplish something. So if you have a different way of accomplishing the automation rules I covered in this video, make sure to share them in the comments below. I love learning about different ways people do things, and it will probably help out others in the community as well. If you found this video helpful, make sure to give it a thumbs up, as it tells YouTube that it should be shared with others. And if you aren't already, consider subscribing to the channel and enabling notifications so you want the first to know when we release other smart home related videos just like this one. Thank you for watching, and as always, happy automating.